Hi, welcome to my YouTube channel. My name is Darlington Nkwazi. Today I'm going to teach you how to determine the pipe sizes of VRF equipment from HVAC drawings. Usually, as HVAC engineers, we do some of these things manually, but then I feel that for one to stand out as a HVAC engineer, one must know how to do some of these things manually because software will not always be available. Okay, so to determine the pipe sizes of VRF equipment from HVAC drawings, there are basically three steps to take. First is to draw a tree diagram containing the indoor and outdoor units with their capacities. Second is to determine the total indoor unit capacity on each branch. Third is to determine the pipe sizes themselves. That's between an outdoor unit and the first Y branch, and then between two Y branches, and then between Y branches and indoor units. Now this is the drawing we're going to be working with. It's a residential building. It has a kitchen, a dining room. It has two bathrooms, a master bedroom, a room for children, a lounge, and a living room. And it uses a VRF system. You can see that there's an outdoor unit over here, serving several indoor units. Okay, and most of the indoor units, in fact, all of the indoor units are wall-mounted units. All right, so yeah, I deliberately removed the equipment schedule so you cannot find the capacity of the indoor units and the outdoor units in this drawing, but you'll see them in the tree diagram that we're going to create later in this video. All right, but this is the drawing that we're going to be working with. Okay, the tree diagram would show how the pipes are routed from the outdoor units to each of the indoor units. Before we go on to determine the pipe sizes of the VRF equipment, there's something I want you to know. Here I have three tables. The first one has to do with the cooling capacity conversion rates. Um, this is something that every HVAC engineer should know. That's how to convert from BTU per hour to kilowatts and to HP. For example, 5,000 BTU per hour is the same as 1.6 kilowatts, which is also the same as 0.6 HP. 7,000 BTU per hour is the same as 2.2 kilowatts, which is also the same as 0.8 HP. 9,000 BTU per hour is the same as 2.8 kilowatts, which is also the same as 1 HP. And we can go on and on until we get to 96,000 BTU per hour, which is also the same as 28 kilowatts, which is also the same as 10 HP. Okay, so that's for table 1. For table 2, this is what will help us determine the pipe sizes, between two Y branches. Uh, uh, and that reminds me, in this video I'm going to use LG products. Okay, so please take note of that. It's important that you understand the brand that you're working with. You have a good knowledge of the brand that you're working with, because each brand has its unique selling points. Okay, of course, whatever I'm teaching you in this video is transferable to other brands. Okay, but just take note of those differences. All right, the principle is essentially the same, but there are just a few changes, okay, here and there. All right, so for table 2, table 2 only applies to LG products. Table 3 also applies to LG products. All right, so in fact, whatever I'm teaching you in this video applies to LG products, although, like I said, a lot of it, a good percentage of it, a good portion of it is transferable to other brands. Okay, but this is a perfect fit for LG products. All right, so for table 2, if the total indoor unit capacity is less than or equal to 5.6 kilowatts, then the right liquid pipe size to use is 6.35 millimeters, while the right gas pipe size to use is 12.7 millimeters. And we can go on and on till we get to 291.2 kilowatts. Anything less than or equal to that, the right liquid pipe size to use is 22.2 millimeters, while the right gas pipe size to use is 53.98 millimeters. Okay. For table 3, this is what will help us determine the pipe size between a Y branch and an indoor unit. Okay, for example, if the total indoor unit capacity is less than or equal to 5.6 kilowatts, then the right liquid pipe size to use is 6.35 millimeters, while the right gas pipe size to use is 12.7 millimeters. Okay, and we can go on and on till we get to 28 kilowatts. Anything less than or equal to that, then the right liquid pipe size to use is 9.52 millimeters, while the right gas pipe size to use is 22.2 millimeters. Alright, so this is where I got table 2 and 3. It's LG's engineering product data book for multi V5 heat pump. I'll just go straight to the pages where I got the tables. This is where I got table 2. It's the table that I said would enable us to determine the pipe sizes between Y branches. I deliberately removed the high pressure side of the gas pipe because my main focus is the liquid pipe and the low pressure side of the gas pipe. Alright, so this is where I got table 2. For table 3, this is where I got table 3. It's the table that I said would enable us to determine the pipe sizes between Y branches and indoor units. Alright, this engineering product data book is easily accessible. It's something that you can find online. You can just Google it. Now we'll proceed to determine the pipe sizes of the VRF equipment. This is a tree diagram based on the drawing that I showed you earlier, and it basically shows how the pipes are routed from the outdoor units to the last indoor units in the kitchen. That's the wall mounted units in the kitchen. Okay, and we can see from here that the total outdoor units capacity is 50.4 kilowatts, which is about 18 HP. Okay, and it is connected to several indoor units, and they have several capacities. Okay, so what we're going to do is determine the pipe sizes of the VRF equipment now. So in order to determine the pipe sizes of the VRF equipment, I've said that we're going to use table 2 and table 3. Okay, so just follow me. First we'll say let's treat the pipe sizes between the branches first. Say branch to branch. Okay, let's call that A. All right, so this will be branch A, then B. We're starting from the right hand side, then E, then F, then G. Okay, so we'll say at branch A, the total, let's call the total indoor units capacity, let's call it TIUC. Okay, and that will be equal to this plus this and this. Okay, so 7.1 plus 7.1, which is equal to 14.2 kilowatts. All right, now 14.2 kilowatts, if we go to table 2, we'll see that 14.2 kilowatts is between 5.6 kilowatts and 16 kilowatts. So we're going to use this row. All right, so we'll say 5.6 is less than 14.2, which is also less than 16.0. okay, kilowatts. Therefore, on the liquid side, the liquid pipe is 9.52 millimeters. That's this. Okay, and the gas pipe is 15.88. Alright, so that's for branch A. Now we'll look at branch B. So at branch B, what's there? Okay, so this is where branch B is, right? This is where branch B is. Okay, so we'll say again TIUC, that's the total indoor units capacity, is initially we got 14.2. remember it's going to be this plus this plus this. Okay, and we know that initially we got 14.2 when we added when we added this to this. Okay, so 14.2 plus 7.1, which is equal to by my own calculations is equal to 21.3. Okay, so we'll say 21.3 kilowatts. Okay, and yeah, we know that 21.3 kilowatts is between 16 and 22.4. So we're going to choose this row. Okay, so we'll say 16.0 is less than 21.3, which is less than 22.4 kilowatts. Therefore, the liquid pipe size to use is 9.52 millimeters, while the right gas pipe to use is 19.05 millimeters. That's this and this. Okay, so that's for branch B. Now we'll move to branch C. So we'll say we know that this is where branch C is. Okay, here. All right, so we'll say at branch C. At branch C, the total indoor unit capacity, that's TIUC, is equal to this again plus this plus this plus this. And remember, just to make things faster, remember initially we got 21.3 kilowatts. Okay, so that's 21.3 kilowatts plus 7.1 again. All right, and that will give us what? That will give us 28.4 kilowatts. Okay, and 28.4 kilowatts is between 22.4 and 33.6, so we choose this row again. Okay, so we'll say 22.4 is less than 28.4, which is also less than 33.6, okay, kilowatts. Therefore, the right liquid pipe size to use is 9.52 millimeters, while the right gas pipe to use is what? Is 22.2 millimeters. Okay, so that's for branch C. Now for branch D, okay, we know this is where D is, right? So at branch D, we can say again TIUC is equal to last thing we got was 28.4. Okay, plus, remember, it's this plus this now plus this and this plus 7.1 again. Okay, so and that will give us 35.5. okay, so that will be 35.5 kilowatts. Okay, and we know that 35.5 kilowatts is somewhere around here. That's between 33.6 and 50.4. So say 33.6 is less than 35.5, which is also less than 50.4 kilowatts. Therefore, the right liquid pipe size to use is 12.7 millimeters, while the right gas pipe to use is 28.58 millimeters. Okay, so that's for branch D. Now for branch E, we know that this is where branch E is, somewhere around here. That's E. Okay, and that will be a total of this, and this. Okay, so we'll say at branch at branch E, TIUC, that's total indoor capacity, is equal to, the last thing we got was 35.5, okay, plus 5.6 now, okay, and that will give us 41.4, so say 41.4 kilowatts, okay, and we know that 41.4 kilowatts is still between 33.6 and 50.4, okay, so we're still choosing this. All right, so the right liquid pipe size is this, while the right gas pipe size is this, okay, so we'll say again 33.6 is less than 41.4, which is less than 50.4, okay, kilowatts. Therefore, for the liquid pipe, the right size is 12.7 millimeters, while for the gas side it's 28.58 millimeters. All right, so that's for branch E. Now we move on to branch F. Okay, so for branch F, this is where branch F is. Okay, so again, it's a total of this, and this. Okay, so we'll say at branch F, okay, the total indoor unit capacity is equal to, the last time we got was 41.1, okay, plus 3.6 now, and that will give us 44.7 kilowatts, okay, and we know that 44.7 kilowatts is still between 33.6 and 50.4, okay, so we're still choosing this and this. All right, so we'll say 33.6 is less than 44.7, which is less than 50.4 kilowatts, okay, therefore the correct liquid pipe size to use is 12.7 millimeters, and again the right pipe size to use is 28.58 millimeters, okay. All right, so that's for branch F. All right, now for branch G, it's different because it is connected to an outdoor unit, directly connected to an outdoor unit, so we won't determine the pipe size here the way we did for the others. The others were basically between Y branches, but now this one is directly connected to an outdoor unit. Okay, so we have to do it, treat it separately. Okay, so we'll say outdoor unit to Y branch, okay, and we'll say at branch G, the total outdoor unit capacity is equal to 50.4 kilowatts, okay, therefore the liquid pipe, okay, you can see, yeah, let's just write it in full. The liquid pipe is 15.88 millimeters, okay, while for the gas pipe is 28.58 millimeters. I'm going to show you where I got this values from. You get these values basically from the catalog. That's how you get the values. You won't determine the pipe sizes the way you did for the others. Like I said before, you just go straight to the catalog and get the correct pipe sizes for the outdoor units. Okay, because these pipes are coming directly from the outdoor units and connecting the Y branch G. All right, so we have to treat it separately. We have to treat it differently rather. Okay, so I'm going to show you how I got those values now. So this is where I got those values. It's LG's multi V5 catalog for Middle East and Africa. That's the 2019 catalog. I'll just go straight to the page where I got those values. Let me zoom in properly so you see it clearly. Remember that the capacity of the outdoor unit is 18 HP, which is the same as 50.4 kilowatts. All right. I've highlighted it so that you see it clearly. From here, we can see that the correct liquid pipe is 15.88 millimeters. That's this, and the correct gas pipe is 28.58 millimeters. Let me highlight them so that you see them clearly. All right, so for the liquid pipe it is 15.88 millimeters, and for the gas pipe it is 28.58 millimeters. So this is how to determine the pipe sizes between the outdoor unit and the first Y branch. All right, this catalog, just like the engineering product data book that I showed you earlier, is easily accessible. It's something that you can find online, so you can just Google it. So now we'll go on to determine the pipe sizes between the branches and the indoor units. For example, we know this is branch A, this is branch B, this is branch C, this is branch D, this is branch E, this is branch F, and this is branch G. Alright, and for branch A, these are the indoor units connected to branch A. That's here and here. Let me just write it here. So say Y branch, say category C, that's Y branch to indoor units. This time we'll be using table 3, okay? And yeah, so we'll start with branch A. As a matter of fact, based on experience, I know that if you look at this tree diagram closely, you see that branch A, branch B, branch C, and branch D have similar indoor units rather. So we say at branch A, B, C, and D, the indoor unit capacity for them now is equal to 7.1 kilowatts. All right, and we know that 7.1 kilowatts is between 5.6 and 16, so it's somewhere around here, right? So we'll say 5.6 kilowatts is less than 7.1 kilowatts, which is also less than 16.0 kilowatts. All right, therefore on the liquid side it's 9.52 millimeters, okay, while for the gas side it's 15.88 millimeters. Okay, so that's for A, B, C, and D, just to save time. All right, so next we'll look at branch E, and then branch F and branch G. Okay, so again, this is A, this is B, this is C, this is D, this is E, this is F, this is G. There's something again that I've observed. The indoor unit is connected to branch E, and the indoor unit is connected to branch F, and the indoor unit is connected to branch G are all less than or equal to 5.6 kilowatts. Okay, so we say at branch E, F, and G, okay, indoor units capacity is less than or equal to 5.6 kilowatts. Okay, so because for example, for example, you see that the indoor unit connected to branch E is 5.6 kilowatts, right? The indoor unit connected to branch F is 3.6 kilowatts, and that's less than 5.6 kilowatts, right? And then for branch G also, the indoor units connected to it is 4.5 kilowatts, which is less than 5.6 kilowatts, right? Okay, so the Y branch, the correct pipe size, the correct pipe sizes to use are in this row. All right, so we will say that how do we express this now? We'll say, okay, we'll say, yeah, we have written that already. You say indoor unit capacity is less than or equal to 5.6 kilowatts. Therefore, the liquid pipe to use is 6.35 millimeters. Okay, right, the right gas pipe to use is 12.7 millimeters. All right, so yeah, we're done with all of them. Now this is the summary of everything that we have done. Here you can see that the combination ratio is 97.6%. The combination ratio is basically the total indoor units capacity divided by the total outdoor units capacity, and we can see that it's 97.6%, which is good. We can also see the pipe sizes that we have determined. That's from the outdoor units to the first Y branch, and then we can see the pipe sizes between Y branches, and then between the Y branches and the indoor units. At the top, you can find the total indoor units capacity at each branch. All right, that's from right to left. All right, and yeah, basically that's the this is just a summary of everything that we have done. In my next video, I'm going to use LATS HVAC to verify what I have done. uh, Thank you for watching. If you like my video, please subscribe to my YouTube channel, and I'll see you in the next video.